Hello everyone, and welcome to the demo of IVAAP external processing. Today we will explore the use cases of integrating a Python process with IVAAP. We will unlock better user experience, accessibility to data, and end-to-end workflow. Let's begin. Here I have a Jupyter notebook. It contains a process for generating a V-shaped curve from gamma ray curve. I kept the algorithm simple. Today we're interested in the integration part of this and not the algorithm. The workflow in this notebook consists of four parts. First is the data in, and here I am loading a LAS file from my local machine. Then there is the algorithm. We are normalizing a gamma ray curve based on the 5th percentile as a clean sand reference and 95th percentile as a 100% shell reference here. And then we fit that curve into between 0 and 1 and save it as a V-shell curve. The third part is the visualization. In order to validate our process, we will plot it on a simple matplotlib plot. And let me do it right now. And we can see that we have a gamma ray curve and we have a V-shell curve closely following the shape of the gamma ray, but normalized between 0 and 1. And the last part is the data out. Data out, where we are saving a new LAS file containing a VSH curve in it. Now, this is a neat little process, but it has some limitations. First, the data in. If I wanted to run this process with a new data set, I would have to export, save on my local machine, and make available to this Jupyter notebook, wherever the LAS file I want to run. With the visualization, we are running a pretty basic plot here. We could, of course, make it more complicated, but that would be more work, and it would still not be perfect. And the third, the data out. After I export data from here, I need to either ingest it into my data source or copy it to a different place to run a different process. Now, let's take a look at this process, but with a different user interface. The alternative here is the IVAAP client. Here I have a dashboard with a correlation view. The track containing the gamma ray curve for each well is colored based on the V-shell curve, as well as the points in this cross plot. Now, I would like to add a new well to this view, and I have previously created a dataset containing wells which have the formations, which I'm interested in here. These wells are grouped, and you can see them in the data tree in pink. I would like to add the 1601 to this correlation view. So let me first take a look at this well, look at its default log and see if I have all the necessary data. Unfortunately, we do not have a V-shell curve here. So what would I do? I could export this log, plug it into my Jupyter notebook, generate a V-shell and re-import it. Or I could just go and search my external services to see if such a calculation is already available in my organization. And luckily, I have one. And take a note of this window. This is where I go anytime I want to find something in my org, from something as an external process. I see that we have some classification processes that someone created, some prediction, but I'm particularly interested in this VSH calculation. I open this process and it prompts me to input some data and to input an output log name. So I'm assuming that this process is generating a new log based on this user interface. Okay, so I want to create a V-shell curve for 1601 based on the data from the default log here. Let's call it something unique. I think my other logs are called calculated. And let's give it a date. And we hit execute. What happens is the request goes to some service. The service does its job and creates a new log. Note that the log instantly appeared in my data tree. So calculated VSH June 20. And let's take a look at this log right here and see that we have the new VSH curve in this log. Now we can use this well to add it to the correlation. But first, let me go and create a tag here to track my data. We can tags is another way to group data in IVAAP. Let's just make them visible so you can see. Okay, correlation view. We adding the A1601, and it will pick up together with the VSH coloring the GR curves track, and everything else works as expected. Now the question is, how did this Jupyter notebook become this service? To achieve this, we had to do a couple of modifications to the original notebook, and the new notebook is right here. The notable changes are the usage of Jupyter kernel gateway as a way to convert a notebook into a web service. So the way that this works, it takes these cells, wraps them into a service, and exposes them as some kind of an endpoint. And in this case, we have a schema and the execute endpoint. Then we have a schema cell, and this cell creates the user interface. And let's run this real quick to show you what this means. The user interface is defined by a protocol called JSON forms. So if we run this little piece, we will get this complicated JSON schema. This schema will then be interpreted by the client to build a user interface. Of course, every time we make modifications, we can restart the service and the client will pick up the changes on the fly and the user interface is going to change. Second is we process the user inputs as opposed to hard coding our input data and parameters. We now take them from the request from the user. Then the data in, it becomes dynamic. So we don't load a fixed data set anymore. We don't have to write the name of the data set in here. We leverage user input and user selection to then dynamically load our data. The algorithm is the only piece that didn't change at all, really. So the core logic of our process stays the same. Then the data out. When we take the computation and we save it back to the original data source to make it available, as you've seen in the process, to make it available in the IVAAP client. The last piece, the last step we need is to take this service and make it known to IVAAP so that it can be used by our users. To do so, we go to administration, and administration is another client. You can see something that's called cloud services. So the external processing, any external processing service fits under the cloud services model. And if we wanted to add a new service, we would just go new, choose a common processor type. There is other types of services we support based on the deployment. We would give it a name, give it a description, and two magic parameters right here. The schema endpoint would tell IVAAP where to get the user interface description or the JSON form schema. And the execute endpoint is where the IVAAP client would send the user selections and everything. Help endpoint lets us validate that the service is still valid and running. Now, notice the groups on the right side. Services don't have to be created by me in order to be ran by me. In fact, majority of services you've seen in that list were shared with me. They are not mine. So entitlement is a core functionality of IVAAP, and it applies to these services as well. In fact, we can go and find the service for the VSH. And look at its properties. Notice that this service is referencing something that's running on my machine. This is a local host. This is exposing another neat functionality in IVAAP. Being able to run from a local environment. So I can develop my processes and my services or my workflows on my local development machine and leverage IVAAP data pipeline and the user interface to run it and to test it. Now let's change something. I don't like this. Let's say calculation by GR. Let's change the name, save it, yes, and go back to IVAAP client. Let's try to open this dialog again. As you can see, any changes to that database is live. And every time I hit open, the latest schema, the latest state of the service is going to be loaded. Okay, so I'm hoping that now you can see how this integration allows the users to leverage company processes from a single digital workspace. I would like to know what you think about it and whether it fits the reality of your work. This demo is over and we can get to conversation. Thank you.